Welcome to an exciting lecture on sustainable design. Today we're going to discuss how the location of a building plays a large role in how to design it for maximum efficiency, and then some other details about green design. So it all starts with the sun. The sun triggers photosynthesis in plants, which then in turn creates all life on Earth, the food we eat, the air we breathe. As our main source of energy on planet Earth, it also creates climate and weather conditions that will or should influence the way that we position a building on the site, determine the size and location of windows and skylights, plan the lighting design, and the amount of heating and cooling required. The sun does not always provide us with good things, though. It also contributes to the deterioration of paints, roofing, wood, and other building materials. Fabric dyes can fade, plastics can decompose. Interior designers really need to plan for this when space planning and selecting materials. Now, there are many things that will affect how the sun reaches your building. The distance from the equator, the altitude, proximity to large bodies of water or maybe no water, and the presence of shade structures like trees and buildings and mountains and other large features. How you orient the building on the site should take into consideration the sun's angles. They will determine how warm the ground becomes when it's struck by the sun. Now, in northern latitudes, the angle of the sun is more perpendicular to the Earth's surface, so it strikes at a lower angle and spreads the waves across a broader surface. This means the sun doesn't concentrate in one area very much and doesn't heat up the ground as much as it does in southern latitudes, where the sun's angles are more directly above the Earth. This occurs most of the year, and then the sun strikes the Earth, at a larger angle, concentrating the sun's heat over a smaller surface. Most all of our energy comes from the sun, with the exception of geothermal, nuclear, and tidal power. Some of this energy is considered renewable and some is not. Now, photovoltaic, where technology converts the sun into electricity, is considered a renewable energy source. Wind power, derived from currents created when the sun heats the air in the ground, is a renewable energy resource. And hydroelectric power, made possible by the evaporation of water driven by the sun, is also considered a renewable energy source. Non-renewable energy comes from the use of fossil fuels, including coal, oil, gas, etc. These also come from the sun, but take millions of years to produce. Essentially what they are is decaying vegetation that's been cooked by the Earth's core and fossilized into fuel. Basically fossilized solar energy. But to create more, it takes millions of years. The U.S. Department of Energy says that Americans get about 85% of our electricity from fossil fuels. Again, because it takes so much time to produce these fuels, there is concern that someday we're going to run out of energy. To prevent this from occurring, designers, architects, engineers, and planners are working to create more infrastructure that relies less on fossil fuels and more on renewable energy resources. This semester, you're going to learn more about many of these approaches in each section we move through. Another environmental concern is the greenhouse effect. Many building products and functions produce gases, which trap heat inside the Earth's atmosphere. This is heat that would have otherwise escaped into space. Now, some of these gases are important. If they were all to dissipate, the Earth would become so cold that it would be uninhabitable. But too many of these gases can result in global warming and temperature change. Power plants and combustible engines are the largest producers of greenhouse gases. So when you design for energy efficiency, you're helping to reduce greenhouse gas emissions. Sustainable design works not only to reduce the amount of fossil fuels burned to build and maintain a structure, but also other negative environmental effects as well. These could include the demand for water, the reduction of toxins and harmful chemicals, waste reduction, and creating an overall healthier environment for the inhabitants. There are 7 R's of sustainability. Rethinking the situation, stepping outside of the box. Redesign for flexibility, durability, longevity, ease of disassembly, ease of maintenance, eliminating the concept of waste. Reduce, do more with less, reduce toxicity, reduce pollution. Reuse, specifying products that can be used over and over again, or perhaps using something in a different way. Renew, specifying products from renewable resources, like cork that can be simply shaved off a tree rather than wood where it requires a tree being cut down. And finally, refurbishing, giving new life to something that already exists. Instead of tearing it out and replacing it, maybe it can just be enhanced. And finally, recycle. Waste from construction sites occupies about 40% of landfills. Recycling should really be the last resort. You should approach all the 6 steps first, but it is important, and if you do need to throw something away, see if it can't be recycled. Now, what makes a product green? There are a lot of companies out there trying to sell green products, but they might not actually be sustainable. First, and I think this one's very important, it should be made from local materials. Not only does it reduce carbon emissions and energy that it takes to ship materials from long distances, but you're also supporting your local businesses. The experts suggest that the materials come from within a 500-mile radius of your building project. Are the materials renewable? Are they recyclable, or can you reuse them? Is it something that's going to break down very quickly, or can it last for a long period of time? Is it non-toxic in its manufacture, use, and disposal? So this is an important thing to think about. Maybe you need to look into how your products are manufactured, as well as what materials they're made up of. And then, of course, what do you do with it when you don't want it anymore? Can it be recycled? Must it be thrown away? Can it be reused? And also, making sure that it's energy and water efficient. Now, to achieve sustainable design, all design professionals must cooperate, including the architect, designer, contractor, various engineers, specialists, and the building owner. Setting goals at the beginning of the design process is the best approach. There are 2 types of sustainability goals: resource reduction and performance enhancement. Now, a resource reduction goal would be something like reducing energy use, reducing waste, water use, material usage, and carbon emissions. Performance enhancement goals would be things like improving the air quality, improving thermal comfort, acoustical performance, and improving light and visual effects of the space. All of these categories relate to the ambient environment. Now, take a minute and pause this video. Jot down a list of things that you could do as a designer to reduce resources and enhance the performance of a space. We'll discuss some of these in class. Next, let's talk about how buildings can be evaluated for their sustainability. The USGBC is a nonprofit organization that represents the building industry, and they have created a system for evaluating the sustainability of a building called LEED, Leadership in Energy and Environmental Design. Now, there are 4 levels of LEED compliance. It begins with LEED certified, followed by Silver certified, Gold certified, and Platinum certified. To achieve a certification, buildings earn points in various categories. Sustainable sites, where they discourage development on previously undeveloped land. look to minimize the building's impact on ecosystems and waterways, and encourage regionally appropriate landscaping. There are also rewards for smart transportation choices, controlling stormwater runoff, and reducing light pollution and the heat island effect. The water efficiency category encourages smarter use of water both inside and out. Water reduction is typically achieved through more efficient appliances, fixtures and fittings, and water-conscious landscaping. According to the U.S. Department of Energy, buildings use 39% of the energy and 74% of the electricity produced each year in the U.S. So the energy and atmosphere category encourages a wide variety of energy-wise strategies, such as energy use monitoring, efficient design and construction, the use of efficient appliances, systems, and lighting, the use of renewable and clean sources of energy, and generated on-site or off-site renewable energy, as well as other innovative measures. During both the construction and operations phases, buildings generate a lot of waste and use a lot of materials, large quantities of materials and resources. So the materials and resources category encourages not only the selection of sustainable products, but it also promotes waste reduction as well as reuse and recycling. The U.S. Environmental Protection Agency says or estimates that Americans spend about 90% of their days indoors. So where air quality can be significantly worse than it is outside, the indoor environmental quality category promotes strategies that improve indoor air as well as those that provide access to natural daylight, exterior views, and improved acoustics. The innovation and design process category is a bonus category, and this provides bonus points for projects that use innovative design technologies and strategies to improve a building's performance that goes beyond what's required by LEED credits. So basically, if you came up with a good idea that's not already listed in their documentation, then they've got some wiggle room to give you extra credit for that. Both the location and linkages and awareness and education categories apply to the LEED for Homes rating system. Now, they see that a lot of the home's impact on the environment comes from where it's located and how it fits into the community. So the location and linkages category awards points to home builders that build within an existing part of the city, infill building, rather than going out to unspoiled desert and popping up houses there. The awareness and education category knows that a home is really only truly green if the people who live in it use its green features to maximum effect. So this category encourages home builders and real estate professionals to give these homeowners and tenants, even those leasing the buildings, and also the building managers with all of the education and the tools they need to properly understand the green features of their building. The regional priority category applies to all of the rating systems and may or may not be in effect in different areas. The U.S. Green Building Council has chapters in different cities in different parts of the country, and there may be specific sustainable requirements for those locations. So that gives those local chapters a little bit of room to add other important requirements to the LEED process. All right, in addition to LEED, there are other systems that rate products, product oversight rating systems. The Forest Stewardship Council is recognized under the LEED system for a third-party certification of sustainable wood products. Energy Star was launched by the EPA, and it provides energy guidelines for building products and appliances. The Master Painters Institute is based on the EPA's guidelines for VOCs, or volatile organic compounds, and is also recognized by LEED. The Sustainable Forestry Initiative is certification for sustainable logging and reforestation. GreenGuard certifies products and furniture, also meets LEED standards. Green Seal provides a life cycle assessment for many products, light fixtures, sealants, flooring, and other materials, also recognized by LEED. And the Carpet and Rug Institute's Green Label Plus program provides ratings for carpets. Now, in order to design a sustainable structure, it's very important to understand the climate that your structure is located in. The climate can determine the building's energy efficiency, water retention, ventilation by wind, noise level, etc., all affecting the user's sense of place. Your site may have a microclimate or different features than those nearby. The proximity to large bodies of water, plants for shading, different wind patterns created by tall structures, heat from machines, noise from the street below, etc. So in addition to considering the regional climate, you should also consider the actual specific local climate that your site is located in. Now, in cold climates, structures focus on heat retention, protection from rain and snow and winter winds. Insulation is very important, and a south-facing wall to absorb most of the sun's rays is also very important. The use of passive solar heating by, again, orienting the building to the south and using dark colors to help retain the heat, minimizing the surface area that's exposed to the wind and the snow, etc., will all help improve the energy efficiency of homes or buildings built in cold climates. In temperate climates, buildings will typically require heating in the winter and cooling in the summer. South-facing walls should be maximized, with shade covering the east and west exposures. Building orientation and landscaping can create shade, and window locations can aid in ventilation. Here you can see in the summertime, a deciduous tree is full of leaves and it blocks some of the extra heat from the sun. Whereas in the wintertime, the leaves fall off and it opens up the space and the sun's able to hit the home, and the home can absorb the sun's rays when it's most needed. Now, in hot, arid climates like Arizona, buildings should take advantage of the wind and the rain for cooling and adding humidity. Windows and patios should be shaded from the sun. Plants and water features can help, again, cool and add humidity to the air. Surfaces should be lightly colored so they reflect as much light as possible. In hot, humid climates, structures should be shaded from the sun as much as possible and take advantage of breezes for cooling and dehumidifying. East and west exposures should be maximized, and windows should be designed so that they can remain as open as much as possible. Many times floors are raised above the ground with a crawl space underneath to also encourage air circulation. Now, multi-story buildings are often designed in layers. So the top layer, or the sky layer, is the most susceptible to the outside elements, but it provides the most privacy and the least amount of noise. The near surface layer is more accessible to people and activities. The surface layer has the most direct public contact, maybe more protected from elements, but will also be closest to most of the noise sources. And the subsurface layer will be the most quiet, provide the most thermal protection, but could also be susceptible to groundwater and leaking. Sustainable buildings are designed to be sensitive to the surrounding climate. The climate of a site is determined by several things: the sun's angle and path, which we just discussed, the air temperature, humidity level, the amount of rain or precipitation that the site gets, how windy it is, how polluted the air may be or how clean the air may be, and then various characteristics of the ground's surface, the plants, the topography, the materials, in the ground. Water on or near the site will lower the air temperature and actually moderate the air temperature if it's enough water. Large bodies of water will keep temperatures at a more constant level. There will be less fluctuation up and down. It also increases humidity, which can be good in certain situations. Landscaping on a site can also lower the air temperature, helps to reduce noise to some extent, improves air quality, reduces the amount of heat that's reflected at a building off the ground, and can also provide privacy if it's large trees or shrubs or that sort of thing. The interior of a building will respond to these site conditions by either opening up to them or turning away from them. Fresh air and sunlight from the outside definitely help improve the quality of experience that a user has in a building and their overall health. Like our skin, the building is the interface between our bodies and the surrounding environment. The more this interface, or building envelope as we call it, cooperates with and responds to the surrounding climate and site conditions, the more sustainable the structure becomes, and the more aware the occupant becomes of their environment.